Late August 1944, 0615 hours. Observation Post 4, Partel, France. The morning report lay crumpled on the desk as German technical officers at Flak Regiment 155W struggled to understand the numbers in front of them. The interception rates broke every rule of ballistic probability taught at Luftwaffe technical schools across the Reich. 82% destroyed. This cannot be right. Through their field telescopes, German observers had seen something that shattered everything their intelligence services had promised about Allied anti-aircraft capabilities. The V-1 flying bombs launched toward London in the early morning were being wiped out at rates no one could explain. They weren't being brought down by fighters pulling risky pursuit curves. They weren't caught in barrage balloon cables. They were being destroyed by anti-aircraft fire over the coastal gun belt. Shells exploding with impossible precision around the missiles, detonating near them instead of needing direct hits. At Flak Regiment 155W headquarters in the Château d'Odo, Oberst Max Vittel, the commander of the entire V-1 offensive, received these reports with rising alarm. Over the course of the German V-1 campaign, the percentage of flying bombs destroyed by the coastal gun belt had soared, from 17% in June to 74% by late August. On one extraordinary day that final week, it hit 82%. August 1944 marked the beginning of the most profound technological shock the Wehrmacht's weapons scientists would face during the war. What neither Tell nor any German scientist knew at that moment was that they were watching the arrival of one of World War II's most closely guarded secrets. A technology so revolutionary it was protected at the same level as the atomic bomb project. The proximity fuse, or VT variable time fuse, as the Allies called it, was systematically destroying Hitler's terror weapon with a precision German physics claimed was impossible. The story had begun 10 weeks earlier, on June 13, 1944, exactly 1 week after D-Day. In response to the Allied invasion of Normandy, Hitler had finally unleashed his long-promised Vergeltungswaffe, the vengeance weapon, against London. At 4:25 a.m. on June 13, the first V-1 struck London, landing on Grove Road in Bow. It destroyed a railway bridge and nearby homes. 6 people were killed, 30 injured, and 200 left homeless. The weapon represented years of German development. A pilotless aircraft powered by an Argus as 109-014 pulsejet engine, carrying 850 kilograms of Amatol explosive and flying at 640 kilometers per hour. It was the world's first operational cruise missile, and the German High Command believed it would bring Britain to its knees. Major Walter Dornberger, head of the V-weapon program at Peenemünde, had calculated that even with a conservative 25% success rate, the V-1 would deliver more explosive power on London than the entire Blitz of 1940-41. Each V-1 cost about 5,000 Reichsmarks to produce, just a fraction of a manned bomber mission, and with no risk to aircrew. At Peenemünde Army Research Center, German scientists had every reason to be confident. They had developed advanced rocket technology, created operational jet aircraft, and now fielded the first cruise missile. Dr. Robert Lasser, the man who designed the V-1's control system, calculated that Allied interception was nearly impossible. The flying bomb raced at 640 kilometers per hour, shifting altitudes between 600 and 2,700 meters. British fighters needed to exceed 650 kilometers per hour just to catch it. And to destroy it, they had to get within 200 meters, close enough to risk being caught in the blast themselves. AS for anti-aircraft fire. The chance of a direct hit on such a small, fast target was calculated at less than 1 in 10,000 shells fired. This wasn't propaganda, it was solid ballistic science. Conventional time-fused shells demanded accurate prediction, precise calculation, manual fuse setting, and perfect timing. At V-1 speed, gunners had maybe 30 seconds from detection to engagement. Oberst Max Vittel, commanding Flak Regiment 155W, knew these limitations all too well, from both sides of anti-aircraft warfare. During the campaign, the Germans launched 9,521 V-1 missiles from ground sites against England, with thousands more aimed at other targets. In total, about 25,000 V-1s were deployed throughout the war. But within days of the first launches, troubling reports reached German intelligence. British anti-aircraft defenses were adapting with suspicious speed. By late June, the interception rate had climbed from 10% to 24%. Higher than predicted, but still explainable. Then came July, and the numbers became impossible to explain. German technical officers tracking the results noticed British guns claiming V1 kills while using far less ammunition than should have been possible. Observers on the French coast saw V1s flying steadily toward England, suddenly surrounded by flak bursts, then tumbling from the sky, even though the explosions were too far away for direct hits. Unknown to German intelligence, they were witnessing proximity fuses, a secret technology that turned near misses into kills. This technology had already been in action in the Pacific since January 1943, when the USS Helena shot down a Japanese dive bomber with shells that exploded the moment they sensed they were close to the target. The German intelligence failure was total. The Oslo report of November 1939 had actually mentioned proximity fuse research, but German scientists dismissed it as disinformation. Germany had tried to develop similar technology. More than 30 different designs were researched, but none ever became operational. German engineers had concluded proximity fuses were impossible. The technical challenges were overwhelming. Miniaturizing radio transmitter receivers for artillery shells, making vacuum tubes survive 20,000 G-forces, creating batteries that could activate after years in storage, and scaling it all for mass production. Yet by August 1944, American factories were producing 40,000 VT fuses a day. During the final week of that month, the proximity fuse reached its peak effectiveness. The British had completely reorganized their anti-aircraft defense system. Their guns now used American SCR 584 radar for automatic tracking. More importantly, they fired shells equipped with VT fuses modified specifically for the V1 threat. The Royal Artillery and RAF Regiment had redeployed from the North Downs to the South Coast, forming a powerful gun belt. This coastal positioning ensured that any dud shells fell harmlessly into the sea, and kept the technology far from German hands. As V1s crossed the English coast, they entered a kill zone where technology crushed the odds. The SCR 584 radar automatically locked onto targets, calculated their trajectories, and fed firing solutions directly to the guns. Inside each proximity fuse were miniature radio transmitters built with tubes developed by Sylvania Electric and Western Electric. When the reflected signals showed the shell was close to a target, thyrotron switches triggered the detonators, blasting steel fragments through V1 hulls. On the peak day in late August, coastal guns destroyed 82% of incoming V1s, a rate German engineers believed was physically impossible. Reports of this 82% interception triggered crisis meetings at German headquarters. Tell suspected sabotage. Emergency inspections found nothing wrong with the missiles. Test firings over German territory showed normal performance. The problem only existed when facing British defenses. German experts concluded that the British had developed revolutionary anti-aircraft systems, but without capturing one of the devices, they couldn't figure out how it worked. They tried everything, flying at different altitudes, launching larger salvos, switching to night attacks, even exploiting bad weather. Nothing worked. The kill rate stayed devastating. At Peenemünde, scientists reached an uncomfortable conclusion. If the Allies had developed proximity fuses, they had achieved what Germany thought was impossible. German efforts to uncover the secret grew desperate, but failed completely. The security around the proximity fuse was almost perfect. Production was split across 110 factories, and workers only knew their own specific tasks, never the full design. Even the name variable time was deliberately misleading. It sounded like a conventional timed fuse, not a high-tech proximity sensor. By 1944, the entire American electronics industry was focused on producing these fuses. By the end of the war, the U.S. had produced 22 million proximity fuses, costing over $1 billion in 1940s dollars. The Crosley Corporation alone made more than 5 million fuses, nearly a quarter of the total production. The numbers revealed a staggering industrial mismatch. While Germany struggled to produce V1s using forced labor, America had transformed its electronics industry to mass-produce fuses. Peak daily production hit 40,000 units. Costs fell from $732 per unit in 1942 to just $18 by 1945. Crosley, a company that had once made radios and refrigerators, now employed 10,000 workers, turning out 16,000 fuses a day at its peak. Sylvania Electric devoted its entire vacuum tube research division to developing ruggedized components, producing 400,000 miniaturized tubes daily. 95% of all tubes used in the program. The contrast was absolute. Germany handcrafted weapons in small numbers. America mass-produced revolutionary technology at a scale the world had never seen. Monthly American proximity fuse production alone exceeded Germany's entire V1 output for the whole war. The proximity fuse was a triumph of engineering. The device had to survive being fired from a gun, withstand 20,000 G acceleration, 25,000 revolutions per minute spin, and extreme temperatures. Sylvania developed miniature vacuum tubes based on hearing aid designs, reinforced to survive these brutal forces. The batteries could remain dormant for years, but activate instantly when needed. Inside, the fuse carried a tiny radio that transmitted signals continuously. When the reflected signals indicated the shell was close to a large object, the circuits triggered detonation, turning near misses into lethal hits. This seemingly simple concept required solving problems German engineers had declared impossible. Quality control was unlike anything seen before. Every single fuse was tested multiple times. Random samples were actually fired from test guns. Rejection rates stayed below 2%, proving an extraordinary level of manufacturing precision on a massive scale. By September 1944, the V1 offensive was effectively neutralized. Out of 9,521 V1s launched from ground sites against Britain, only 2,515 reached London, killing 6,184 civilians and injuring 17,981. While tragic, these losses were just a fraction of what Germany intended. General Frederick Pyle, commander of Anti-Aircraft Command, calculated that without proximity fuses, V1 casualties would have been 4 to 5 times higher. The proximity fuse saved London from devastation. Germany tried night launches and switched to the V2 rocket, which flew too fast to intercept. But these desperate measures couldn't change the outcome. The V1 became a costly failure, draining resources desperately needed elsewhere. Germany's failure to detect the proximity fuse became one of history's greatest intelligence disasters. Despite vast spy networks and technical expertise, the Germans never understood what they were up against. The program remained completely secret throughout the war. Not a single intact proximity fuse ever fell into German hands during the V1 campaign. Incredibly, during the Battle of the Bulge, German troops captured an American ammunition dump containing proximity fuses, but they didn't recognize them. Their firm belief that such devices were impossible blinded them to the truth sitting in their own hands. After Germany's surrender, interrogations revealed complete German ignorance of proximity fuses. Oberst Max Vachtel told Allied officers they had only suspected improved radar or faster fuse settings, but never imagined self-thinking shells. When German scientists were shown captured American VT fuses, they were in disbelief. They couldn't comprehend how vacuum tubes could survive such acceleration, how batteries stayed viable for years, or how circuits functioned perfectly after being fired from a gun. They estimated they were 10 years behind American technology. Dr. Merle Tuve, who led proximity fuse development at Johns Hopkins Applied Physics Laboratory, later reflected that the fuse's success came from systematic collaboration between scientists, engineers, and production workers, something totalitarian systems simply couldn't achieve. The proximity fuse proved that the outcome of World War II was decided not just on battlefields, but also in laboratories and factories. While Germany chased after exotic wonder weapons, America focused on multiplicative technologies, innovations that made existing weapons far more effective. The proximity fuse made every anti-aircraft gun 5 to 10 times more effective. Secretary of the Navy James Forrestal stated, "The proximity fuse has helped blaze the trail to Japan. Without the protection this ingenious device has given the surface ships of the fleet, our westward push could not have been so swift, and the cost in men and ships would have been immeasurably greater." The V1 program relied heavily on slave labor. Tens of thousands of concentration camp prisoners died in underground factories manufacturing V1s. Meanwhile, American workers voluntarily worked overtime for premium wages. They didn't know exactly what they were making, only that it mattered. At Sylvania's Ipswich facility, more than 5,000 women worked 12-hour shifts producing specialized components. They only learned after the war that their work had helped save London from Hitler's terror weapons. The proximity fuse secret held completely. Even British anti-aircraft crews didn't know what made their shells so effective. They were simply issued special ammunition with strict accounting. Every proximity-fused shell fired at V1S was tracked. Any unexploded shells were secured immediately. Naval vessels patrolled the channel, making sure no German forces could recover duds. This secrecy came at a cost. Allied ground forces were not allowed to use proximity-fused artillery until December 1944 to keep the secret safe. Thousands of soldiers died because the technology was too secret to risk. Yet using proximity fuses against V1S was justified. London's survival during the invasion was crucial. For Germany, the V1 program drained critical resources while delivering almost no strategic impact. Launching approximately 25,000 V1S cost millions of Reichsmarks and diverted resources from fighter aircraft and anti-tank weapons that were desperately needed on shrinking fronts. The program's reliance on slave labor added a moral dimension to its failure. The proximity fuse was defeating weapons built through human suffering, a contrast fully understood only after the war. The proximity fuse represented a transformation in warfare, victory achieved through engineering and production rather than individual weapon superiority. It proved that modern war was a contest of industrial systems, not just armies on the battlefield. Before saving Pacific Fleet ships and enabling Japan's defeat, the proximity fuse saved London. Germans watching V1S fall from the sky never understood why. The technology that defeated them was inconceivable within their scientific framework. The shift was dramatic. Before proximity fuses, destroying a single V1 required about 2,500 heavy anti-aircraft shells. With proximity fuses, that number dropped to just 100 shells. The gun belt's interception rate soared from 17% to 82% in just 10 weeks. This wasn't achieved through courage or training. It was achieved through mass production of advanced technology on a scale Germany couldn't match or even comprehend. America had mobilized its entire electronics industry, employed over 80,000 workers, and invested more than $1 billion to produce 22 million fuses. The proximity fuse was finally declassified in September 1945. The War Department's announcement began. One of the most important weapons developed during the war, surpassed in effectiveness only by the atomic bomb. 4 German scientists who had spent months puzzled over V1 failures. The revelation brought both understanding and humiliation. They had been defeated not by strategy or bravery, but by industrial power they had never imagined possible. Post-war interviews revealed German shock. They had believed their V1 represented the pinnacle of weapons technology. Learning that it had been defeated by mass-produced electronics costing less than $20 each was devastating. They had lost not to warriors, but to assembly lines. The proximity fuse technology went on to evolve into modern air defense systems, radar altimeters, and advanced electronic warfare capabilities. For Germany's former weapons scientists, it became a lasting reminder of how blind they had been during the war. The proximity fuse proved that in modern war, mass-producing good technology matters more than building perfect weapons. Germany built brilliant individual weapons. America built millions of effective ones. On that remarkable day in late August 1944, when proximity fuses destroyed 82% of the German V1 rockets, the nature of warfare changed forever. The Germans launching their vengeance weapons had no idea what invisible technology was defeating them. They had followed their own logic, developed advanced weapons, trained elite crews, made real breakthroughs. Yet they were beaten by simple, mass-produced electronics they could never have imagined. The proximity fuse saved London through thousands of small explosions, each one guided by technology German science said was impossible. It was the triumph of industrial democracy over totalitarian engineering. Mass production defeated crafted perfection. Simple solutions multiplied to crush complex wonder weapons. The Germans never found out what was hitting their V1S as they fell, burning from the sky, destroyed by a secret they couldn't imagine and an industrial power they couldn't match. The proximity fuse turned Hitler's vengeance weapon into London's shield. The Germans didn't understand how or why until it was far too late. In the end, America's greatest victory didn't happen on the battlefield. It happened in its factories. Millions of workers, many of them women who didn't even know what they were making, built the tiny electronic devices that saved a city and changed warfare forever. The 82% interception rate reached in late August 1944 proved a new truth. In modern war, industrial strength can crush any miracle weapon, no matter how advanced. The proximity fuse was more than just a weapon. It was proof that democracy's power to unite science and industry could defeat tyranny's forced brilliance. And as German crews watched their perfect weapons fall from the sky, they didn't realize they had already lost a war their leaders still claimed they could win.